What's up, guys? So this is usually the most underrated section of CAD. People don't really focus much on log, but then at times one or two questions do come from this chapter. Even if not in CAD, you'll surely have uh, questions on this topic in other exams, especially ZAT. And we'll soon get to know that how questions can be tweaked in this chapter. So guys, let's start with the session now. So before we start this topic logarithm, it's very important to clear some terminology, like terms like exponent, what is base, what is log. Hence, let's understand. If we are writing an equation such as a to the power x is equals to b, so this is of course an exponential equation. It can be like 2 to the power 3, 2 to the power 4, 2 to the power 5, 3 to the power 9, 2 to the power minus half. So anything of this sort, whenever there is any power, so this is a generic expression of that power value equation, a to the power x equals to b. Here, x is the exponent and a is the base. Now, I can take log on both the sides and I can rewrite this equation as log b to the base a is equals to a. Is equals to x. So guys, how do I derive from equation 1 to equation 2? What I'll do is, I'll just take log on both the sides. So this becomes x log a is equals to log b. Now it's simple, x will be log b by log a. Now log b by log a is same as log b to the base a. We'll also have a look at all the properties, and even this property will be included in the subsequent slides. But for now, you can just understand that log x by log y is same as log x to the base y. That's it. Here, so this is the basic definition of exponent and how do we derive and how can we convert every exponential function to logarithm function. In exam, we typically talk about two different kinds of exponent functions, and there is a sort of confusion that what is the default base. Do we consider e, which is 2.77 and so on and so forth? It's an irrational number, so 2.7 something something, whether this is the base or whether a 10 is the base. This is a very common confusion which happens. So let's understand that we have two different kinds of logarithm. One is natural logarithm. What is natural logarithm? Natural logarithm are those functions which have base as e, exponential. And second is a common logarithm. We also consider this as by default. So for instance, if I am given a number, say log x, and if no base is mentioned in the question, I will by default consider 10 as my base. That is assumption. So remember this, when no base is given, we consider 10 as the base. And that is common logarithm. That's it. Clear, guys, so far? So, but I have quoted the phrase function here. So whenever we talk about functions, there are two very important things. One is domain and second is range. So of course, even logarithm function has a domain. So let's understand what can be the domain. So here, guys, if you see log b to the base a, there are two variables. One is this, which is called as the number, and second is this, which is called as the base. This is base and this is number. So guys, this number has to be always positive. We are talking about the domain of logarithm function. Please pay attention. Such questions come in as a part of quadratic equation. So number has to be always positive. Now, since I have mentioned that you can write this as log b upon log a, so we know whenever we have a term in denominator, this term cannot be equals to 0. Now, if log a is not equals to 0, this implies a cannot be equals to 10 to the power 0, which is equals to 1. Hence, the base cannot be equals to 1. Also, for this log a to be defined, as I've just spoken, a has to be greater than 0. So even here, a has to be greater than 0. So the base should not be equals to 1, else we'll have a term of 0 in the denominator, and every variable should be positive. That is the domain of logarithm. So domain we have cleared. B has to be greater than 0 and A has to be greater than 0 and A can't be 1, because if A is 1 then the denominator becomes 0. Now guys, the next concept is the most important concept in this chapter. That is, how do we predict the sign of log? Whether log, because please pay attention that here I've talked that the variables A and B can't be negative. They can't be negative or even 0. Fine. And A to can't even be equals to 1. But that does not mean that the value of the function, which is log B to the base A, it can't be negative. Log B to the base A has a range of R. It can take any values from minus infinity to plus infinity. Fine. So how can we, very quickly say that this log is negative or this is positive? There is a trick to this. And what is the trick, guys? Always you have to note the sign of A and B. If A and B are on the same side of unity means 1. If they both are on the same side of 1, what does that mean? Same side matlab ya to both A and B will be greater than 1. A and B both are greater than 1. So on the real line, they both are on the same side of unity. Or if A and B, if both are less than 1, and of course greater than 0. Okay? If we have both of these values here, then if both the variables are on the same side of unity, then the value of log, which is log B to the base A, will always be positive. You can remember this as a theorem. The proof is also easy. You'll be able to visualize yourself. If not, if you still are interested in the proof, you can ping me offline. But for now, just remember that if A and B are on the same side of unity, then the value of the log will be positive. Having said that, the vice versa also holds true, that if A and B are on the opposite sides of unity, then the value of logarithm will be negative. Which means, let's see some example. Log 3 to the base 0.3. This will be negative. I can directly say. Why? Because 3 is greater than 1 and 0.3 is less than 1. Log 71 to the base 69 is positive because both are greater than 1. Log 69 to the base 105 will be always positive. Even guys, log 0.3 to the base 0.7 will be positive. Why? Because both 0.3 and 0.7 are less than 1. But if I say log 0.3 to the base 1.2, this will be negative. Why? Because this is less than 1 and this is greater than 1. Log 1.7 to the base 0.9 will be negative. Clear, guys? So what did we learn? The value of log, which is x, will be positive if both A and B are on the same side of unity. Value will be negative if they are on the, this is by mistake, this has to be opposite sides of the unity. And the value will be 0 when B is equals to 1. Why? Because x is what? X is log B by log A. I know, guys, if B is 1, then x has to be 0, right? So if B is 1, x will be 0. So that's it. These are the 3 theorems. Clear, guys, so far to everyone? If you have doubts, please ask me. If not, let's move ahead. Now, guys, the next thing which comes into picture is the binomial expansion, or, you'll not say this as a binomial expansion, but this is an advanced level of series, which is usually termed as Taylor's expansion. So at times, it's good to remember in exam if you already know the Taylor expansion of exponential function and logarithm function. So guys, I'm assuming that everyone is making notes. Everything which you find important, please write it down in your notebook so that you can just revise them and you don't have to visit the entire 2 or 3 hours of PPT before your exams. So all these theorems and everything, use a colored pen, use red, black, green, pink, blue pen, and do it. So yeah, I was talking about Taylor expansion. So these are the 2 Taylor expansion, which means that e to the power x is same as 1 plus x square by 2 factorial plus x to the power 3 by 3 factorial plus so on. So generic term of e to the power x expansion will be x to the power n upon n factorial and this is summation when n goes from 0 to infinity. This is the expansion of e to the power x. Just, remember this. What are the application of these? How can we use this? I'll show you in the subsequent slides. I have added one question directly on the application of Taylor's expansion. So you'll be able to understand better. This is the expansion of e to the power x. Yes, you have to remember this. There is no shortcut. But at least, engineers would have seen these expressions back in class 11th or 12th, or maybe during your JEE preparation if you guys have done. Next is log of 1 plus x to the base e. Please note that here the base is e. This is the natural logarithm. This is not the common logarithm, right? This is this one, natural logarithm. And term is 1 plus x. So expansion of log of 1 plus x to the base e is x minus x square by 2 factorial, sorry, x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 and so on and so forth. So if I have to write a generic term, I know when the power is even, the sign is negative. So minus 1 to the power n plus 1 x to the power n upon n summation. That's it. N goes from 1 to infinity. This becomes the generic term of log of 1 plus x to the power e. Guys, it's very easy to write the generic term, right? You just have to analyze the pattern. See, here first, second, third. Third term has x cubed, so nth term will have x to the power n. Third term has the denominator 3, so nth term will have the denominator of n. Now we only have to take care of sign. In third term, sign is positive, and fourth it's negative, which means for every even term the sign is negative. So if we have a power of n, the minus 1 to the power should be either n plus 1 or n minus 1. You can do whatever you're comfortable with, but because it's going to have the same answer, because minus 1 to the power square is equals to 1. So this becomes the generic expression of log of 1 plus x to the base e. That's it, guys. This was the most heavy slide of the entire chapter, but yeah, if you have doubts here, please ask me. Shatakshi, log b to the base a equals to log b by log a. Yes, Shatakshi, that is correct. Log b to the base a is same as log b upon log a. Right? Now, since there is no base, I'll assume 10 is the base. And for this expression to be positive, since base is greater than 1, b has to be greater than 1, and a has to be greater than 1 if, log b has to be positive, and that's all. So let's move ahead. So guys, as I have told that, the value of log can range from minus infinity to plus infinity. It can be integer, it can be a decimal as well. So for instance, the value of log is, say, log x is, if I say you log x is 4.372, etc., etc. Right? So at times, a question comes that you have to calculate the number of digits in an expansion given certain values of log. We'll come to the application part later. First of all, let's clear the theory. So the logarithm of a number consists of two parts. One is, of course, this is the integral part, and this is the decimal part. Here it can be negative as well, minus 7.325, and so on and so forth. So guys, the integral part is called as the characteristic, and the decimal part is called as the mantissa. If I remember correctly, some of you, maybe Rahul or Himadri, someone has posted in the other WhatsApp group of PrepZone about these terms, characteristic and mantissa, and have highlighted that we'll cover these topics when we'll be studying logarithm. So this is your answer to those questions. So what is characteristic? Characteristic is the integral part of the value of the log. And what is mantissa? Mantissa is the fractional part or the decimal part. But always remember this small thing which I've mentioned in the bracket, positive. So this is the most important thing to note here. The decimal part has to be positive. If it's not, you have to make it positive. And that's when you will call the fractional part as your mantissa. Having said that, let's do a question. This is an example. If the value of log some 3257 is 3.5128, what is the characteristic? This will be the characteristic because this is the integral part and this is the fractional part. Anything after point is the fractional part and anything before point or a decimal is the integral part. So 5/28 becomes the mantissa. Of course, this is positive. So this condition holds true and characteristic is 3. Let's see a next question. Let me give this question to you first of all and then we'll solve this. If I say that the value of log x is minus 3.4328, find the characteristic and mantissa of this question. Solve everyone. This is hardly a 20 to 30 seconds of question. Guys, it's a simple problem. The value I've already given it to you. So try to break this. Hint is minus 10.5 is same as minus 10 plus 0.5. Sorry, minus 10 minus 0.5. Now, this is the fractional part. If you have to make it positive, what you have to do, you just have to do a plus 1 and minus 1. Club this minus 1 with the fractional, with the integral part. So this becomes minus 11 plus 1 minus 0.5. So this is 0.5. So now the mantissa part is positive and then this is the mantissa and this is the characteristic. This is the hint. At least now guys solve. Guys, it's simple. 1 minus 0.4328. So 1 is what? 1000? Sorry, 10,000. So it's same as 10,000 minus 4,328. So guys, 100 minus 28 is what? 100 minus 30 is 70. So 100 minus 28 will be 72. So the last two digits have to be 72. How can it be 92 or 68? Good. So yeah guys, it was simple. Minus 3 minus 0.4328. I'll do a plus 1 minus 1. So my characteristic will become minus 3 minus 1 and mantissa will become simply 1 minus 0.438. Now this is a very simple calculation you have to do guys. So mantissa is 0.5672 and characteristic is minus 4. So guys, the main crux of this slide is, it should be remembered that the mantissa is always positive. This is the concept of this slide, while characteristic can be either positive or negative. Then guys, now let's have a look at the properties of logarithm. First property, guys, here the key to remember the properties is try to analyze the pattern. So if I'm saying, as in like, proofs are really simple, but then I don't think you guys should go into proofs for now. Just understand and try to analyze the pattern. A to the power log A to the power log n to the base A will be equals to n. So how do I remember it as? If I have any term like, A log A, this will just get cancelled and the final answer will be n. That's it. That's how I remember. Next is log. The number is a to the power x and the base is b to the power y. Now, the key to remember this is that, guys, the exponent of the number part comes directly outside. So for instance, log a cube is same as, I can directly take this 3 outside. So this becomes 3 log a. However, if I have a number in the base, that becomes reciprocal. So that comes in the division part, which means if I have log x to the base a cube, this is same as 1 by 3 log x to the base a. Now I've just compiled these two properties to write my final property as that the exponent of the number part comes directly outside and the exponent of the base comes as 1 by that value. That's it. Next property is, let me erase everything. Yeah, third property is log b to the base a is same as Shatakshi also asked, this is same as log b to the base a. Now, whatever base I want to give to both these variables, I can do it. The key is the base should be same. It can be xx, it can be yy, it can be 10, 10, it can be 5, 5, it can be 0.1, 0.1. whatever you want to do it, because essentially this will be what again, log b by log x, and this will be log a by log x, and log x will get cancelled. So whatever is the value of x, that doesn't really matter here. Okay, so I can change the base. This is the base changing theorem. Log b by log a, I have converted the base from a to x. Next property, log a to the base a is 1. That's very simple. Or I can now write that the number is here. This is the base. So the base to the power final value, because I know that if log a to the power b is equals to x, I can rewrite this equation as a equals to b to the power x. Right? This was the first line of the first line. Hence, it's the same thing. Next result is, guys, log ab is equals to log a plus log b. Guys, here a couple of times people confuse this identity with log a into log b is equals to log of a plus b. But guys, there is no identity like this. The identity is, if the number terms are in multiplication, you can split them. Hence, application can be, I can write log 6, which is 2 into 3, as log 2 plus log 3. At any point of time, if you're having issues, you can just mention in the comment box. Similarly, guys, I have a property of division. Log of a by b equals to log a minus log b. If you guys are smart enough and you don't want to remember two things, what you can do is, I have already learned the property of log a by b, log ab. So if I'm saying that, guys, log ab is equals to log a plus log b, from this I have to calculate log of a by b. What I will do, I will simply replace b by 1 by b, and I'll get this equation. So if I do this, the final result should also be in the same proportion. So log a, I have to replace b by 1 by b. Log 1 by b is log of 1 by b is what? B to the power minus 1. I can bring this outside. So this is minus log b. Hence log a minus log b is the final identity. This is the proof. Next is log a log b to the base a. You can anytime change the order of number and the base and reverse these equations, because it's what? The proof is, this is what? Log b by log a. This will be log a by log b. Now since it's 1 upon log a by log b, so this essentially becomes log b by log a. That's it. I'm clearing everything. Next property, log a 1 by b. It's very straightforward, because 1 by b is same as b to the power minus 1. I can bring the exponent part of minus 1 outside, and this becomes minus log b to the base a. That's it. Let's move on to the next side. Yeah, guys, this is the most important property. I can change the order of C and A. So A to the power log C base B is same as C to the power log AB, which means 2 to the power log 5 to the base. Say the base is 2, right? If you guys have to calculate this, what you can simply do is interchange the value of this 5 and this 2. So this becomes 5 to the power log 2 to the base 2. Now we know this value is 1. So I can very simply write the final answer as 5. Now guys, if you see, this property is directly an application of this, right? Just put A equals to B. So the final answer will be C, which is equals to N here. That's it. Let's move on to the next property. Yeah, next thing which I want you guys to analyze is log x to the power base A is a decreasing function if the value of A lies between 0 to 1. The reason I'm saying this is, first of all, what do we mean by decreasing function? Decreasing functions are those functions where if I increase the value of the variable, the final value of the function decreases. So for instance, 1 by x. If the value of x increases, the final value of y would decrease, right? So any function where graph is somewhere, sloping downwards like this. So the value is decreasing as the value of x increases. Or guys, if you see here, we can also see that the slope will always be negative for the decreasing function. And hence, if I do a differentiation, dy by dx, if y is a function, that will always be negative for a decreasing function. Now, if I say so, this is what? Log x upon log a. This is for the engineers, the proof. Others, I'm not sure if you are able to relate, but if you can, it's very good. I'm rewriting this expression as log x by log a. I have to differentiate this. Log a is constant, so this will remain outside. Now, guys, the differentiation of log x is 1 by x in its domain. Hence, I can say because a is between 0 to 1 and the base is by default 10, so these are on the opposite sides, hence this value will be negative. So this value is negative for all the positive values of x. This value will finally become negative. So it's just on the detailed proof point where I'm going into. But for now, you can just remember if the value is between 0 to 1, this is a decreasing function because this is log x by log a. Log a is negative. So as the value of x increases, I know when x is 1, the value will be 0. When x is somewhere here, the value is negative. And this is a typical graph of log x, right? So as the value of x increases, log x is increasing, but since the base is negative, the value will be negative, and hence this is a decreasing function. Vice versa is, this will become an increasing function if the values a is greater than 1. Why? Because the base will become positive. That's pretty much. Next theorem is, if guys, this is given to you that the value of log x to the base a is greater than or equals to log y to the base a, does it necessarily mean that x is greater than y? Or greater than or equals to y? No. Why? Because again, this is log x by log a greater than or equals to log y by log a. Now guys, log x will be greater than or equals to log y, and hence x will be greater than or equals to y if this log a is positive. But log a can be negative if a is between 0 to 1, right? And hence I say that x will be greater than or equals to y if a is greater than 1, and x will be less than or equals to y if a is less than 1. Clear guys? This is a very simple application. If you pay attention in the class, you won't even have to revise everything. This should get directly into your head. And you're anyways writing notes, so it becomes easier to just revise. So yeah guys, let's have a look at other properties as well. So for now, you don't have to exactly memorize and ratify every property. It's very intuitive. So yeah, these are the few properties. If x and y are positive real numbers, okay, and a and b are the rational numbers, okay, then this is directly base changing theorem. It's same as 3 by 2 to the base 1 is same as 2 by 3 to the power minus 1, right? It's very simple. The sign is changing from minus a to plus a, so the value will reverse. X to the power 1 by a is same as eighth root of x, right? This is the representation. X to the power half is root x. By default, root is 2. X to the power 1 by b is, this is x to the power a to the power 1 by b. So 1 by b is the bth root of x to the power a. And this is the expression. Eighth root of x into eighth root of y is equals to eighth root of xy. Clear? Eighth root of x by eighth root of y equals to eighth root of x by y. Very intuitive. This is the conjugate property. 1 by root n plus 1 minus n equals to this. How do we derive? We have studied in the equation, we always multiply with the conjugate pairs. So if we do this, this is a plus b into a minus b equals to a square minus b square. So root n plus 1 square minus root n square, solve this to get 1, and hence the numerator becomes the final value. That's it. Let's move ahead. So yeah, if guys, the value of log a is given to you in the question, only if, I'm repeating my statement, only if in the exam the value of log A is given to you, then apply this formula. That if you have to find the number of digits in a to the power b, it can be anything. A and b can be any damn thing. Of course, a has to be positive, only then log a would be defined. B can be anything, positive or negative. Then the number of digits are integral part of log a to the power b plus 1. That's it. Okay. Why I'm saying is, a lot of people assume that the value of log 2 is 0.3. But no guys, it's a long value. It's 0.3010 and so on and so forth. So even if you make an approximation, that is going to hamper your final answer. Because if this is being multiplied by a big number, say b is 10 to the power 5, then this will definitely make a difference in your final answer. So don't apply this unless the value of log a is given to you in the question. Having said that, let's solve a question. Find the number of digits in 2 to the power 47 given that log 2 is 0.3010. Yeah guys, solve this. It shouldn't take much time. It's a 10 seconds of question. Just a very direct application of what we just learned. Perfect guys. The answer is 15. You all are absolutely correct. It was very simple, right? Integral part of log 2 to the power 47. So log 2 to the power 47 is 47 log 2. Log 2 ka value is given 0.3010. I will just multiply this. The value will be something like 14 point something. So integral part is 14. So final answer will be 14 plus 1, which is 15. That's all. Here. So guys, that was pretty much in the concept part of log. The topic of log goes hand in hand with the topic of surds. So let's also have some concept on surds and then we'll solve joint questions. So what is surd? The term surd means any irrational number. Any damn irrational number, root 5, root 2, root 1 by 3, root 7 by 4, anything which is an irrational number is a surd. What is an irrational number? Irrational number are those real numbers which are not rational, because we know the definition of rational is any number which can be expressed in the form of a by b is a rational number, right? Hence, irrational are any number which cannot be expressed in the form of a by b but are real. Those will be irrational or surds. At times, we also talk about surd pairs. What are surd pairs? It's, as the name suggests, it's basically conjugate pairs. So like surds. So next term is like surds. What are like surds? Like surds is a term. These are those surds which have the same irrational part and they can be added or subtracted. For example, 6 root 2 plus 3 root 2. 6 root 2 plus 3 root 2. The irrational part is root 2. Root 2 is common, so they can be added and the final answer will be 9 root 2. That's it. These are the like surds, 6 root 2 and 3 root 2. Three properties are, if a plus root b equals to c plus root d, how do we solve this? The non-surd part, the rational part which is a and c, they have to be same, and the irrational part root b should be equals to root d. Hence b should be equals to d. The conjugate of a plus root b is a minus root b, just the sign changes. The same applies to a plus iota b. If it's a complex number, the conjugate of a plus iota b is a minus iota b. And the final property is this. Root of a, root a, root a, root a, root a till infinity is equals to a. If someone asks me that, sir, how do we prove this? Assume this value is x. Infinity. If I am assuming this value is x, if I guys just leave one bracket, this value is essentially again x, because nothing has changed. I've just taken one term apart from the infinity. So infinity minus 1 is same as infinity. So this value will again be x. Now I can rewrite this expression as under root of ax is equals to x. Square both the sides. Ax is equals to x square. X is definitely non-zero, so I can cancel x. So final x will be equals to a, and that is the property that this final value will be a. Perfect, guys. So that's all about the concept part of logarithm and surds. Now let's apply the concepts we have learned and let's just solve questions in the remaining part of the chapter. Solve this. The only key point here is, guys, this is essentially 7 to the power First of all, you'll solve the bracket. 3 to the power 2 is 9. So this is 7 to the power 9. And this is 7 cube square. You can actually multiply these terms, and this is same as 7 to the power 6. So the concept is a to the power b. If you know something like this is given, this, then this is same as a to the power bc. That was the only concept. Yes, the final answer is b. Very good. Now guys, the next question is my really interesting question, and let's see who can solve this. What is the value of 7 to the power 3 to the power 2? You don't have to solve, you just have to simplify this expression and give me the final expression. That is it. I don't want you to calculate the final value for now. This will help you in questions of number system. Say questions are asked. So this is a perfect example of indices, which is also a part of this topic, logarithm, surds, and indices. There can be a lot of answers here. What is it? Is it 7 to the power 6 or 7 to the power 9 or 7 cubed to the power square? I think there can be only 3 values, right? 7 to the power 6, 7 to the power cube, whole power 2, or 7 to the power 9. There can be only 3 options in my opinion. So which one? Perfect, guys. So let's learn. The final answer is 7 to the power 9, a to the power, b to the power, c to the power, d to the power, e. You always solve from up. So you'll first of all solve d to the power e, then you'll solve c to the power x. If this is y, then you'll solve b to the power y, and then if this is z, then you'll solve e to the power z. Hence 7 to the power 3 to the power 2, this becomes 9, and hence answer is 7 to the power 9. That's it. So yeah, the final answer will be 7 to the power 9. Now if this concept is clear, let's solve one question. This is the question. If 16 is equal to a to the power b to the power c, find the minimum value of e plus b plus c. See, 343 to the power 2 will be, this is 7 cube to the power 2. This will be 7. Last concept was, this is, you multiply these two terms. This will be 7 to the power 6. What Ashutosh is saying, if this is 3, sorry, if this is 3, then yes, 3 into 3 is 9. So this becomes 7 to the power 9. That's it. Meanwhile, solve this question. For your clarification, let me put a constraint. Let a, b, c be integers. This is the extra condition which is given to you in the question. Now solve it. I'll give you 30 to 60 seconds more. Let's see who can solve this. The hint is your concept in the entire maths have to be really strong to be able to decipher this question. The answer is, it's not defined. Why it's not defined, guys? Let's see. It's not defined not because it is infinity, which was mentioned by Shivam. It is not defined because the minimum value can be anything. It can be minus infinity. Why? See guys, 16 is a to the power b to the power c. I've always told you that first of all we solve b to the power c. If this is what we have to solve, I can write this as 16 to the power b to the power c, right? Now if I want this value as 1, it can be 16 to the power, or you know, because minimum is asked. Okay, fine, 16 to the power. If I put this value as 1, now I can put any value of c, right? It can be say minus 10 to the power 1000. This value will always be 1 and the final answer will always be 16. But now the minimum value is a large number in negative. Or what I can do is, I know whatever value I mention here of b, if the exponent is 0, this value will again become 1. So this is same as 16 minus 10 to the power say 10,000. This is the value of b to the power 0. So if c is 0, again this will become minus infinity. So since minimum value is asked, it can be anything. Sharjil, it's not infinite. It is minus infinite, right? Minimum value. One term of B or C has to be negative, and it has to be negative, huge number in negative. Himadri, answer 16 नहीं आएगा. You have to do 16 minus say 10 to the power 10,000 plus 0. This will be a very huge number in negative. So answer will be minus infinity, something close to minus infinity. Shatakshi, you can take any value of b, right? See, the point is, so Shatakshi, even 0 is an integer and even minus 10 to the power 10,000 is an integer, right? I think there is something wrong with the concept of integer. Integer can be any natural number or negative natural number or even 0. Minus 10, minus 100, minus 1 lakh, plus 1 lakh, 0, everything is an integer. So b can be anything. B can be minus 10 to the power 10,000. This will be what? Minus 1, 0, 0, 0, 0, 0, 0, so on, right? My idea is take anything, and even 0 is an integer. So yeah, you can either put 1 to the power and then negative number, or you can put any negative large number to the power 0. The answer will be 1, and you can take the value of a is 16 to get the final minimum value. Clear? So let's move on to the next example. This is the question. It's a very, very simple question. Ideally, I would want you to solve it without pen and paper. If you can. If you can't, then take pen and paper. So yeah, the answer will be 2. How do we solve this, guys? It's very simple. Represent this as log xyz upon log xy. Similarly, the log xyz will be common, and hence this will become log xy plus log yz plus log zx by log xyz. You can multiply these 3 terms, just the numbers. So this is x square, y square, z square. So 2 will come common. This is x, y, z whole square. So 2 will come common. This is log x, y, z, and then the answer will be 2. And guys, it's simple. So don't make silly mistakes here. We cannot afford. It's a straightforward problem. Overall answer is 2. How do we write this?